Hello and welcome to my channel Flexmaster. It's purely for technical education and printing and packaging. Previously we have studied chapter number 1 for flexography and packaging, and we will continue today the same. So we have left last chapter subject the analogs, rollers, capabilities and all. So we will continue right now. Chapter number 2. Let's start. Central impression press. Normally it is 4 to 8 colors, wide web, limited to one side printing. Ideal press for handling hairline register at high speed on stretchable films. Longer make ready times required because printing units are more difficult to access. The second type is stack press. It's also designed usually 1 to 8 colors units. Some presses can print on both sides. Trap should be not less than 1 by 64 from inches for thin films. Often used in line with other converting operations such as lamination, rotary and flatbed die cutting, and side sealing bag converting. The third one is inline press. Up to 12 color units can print two sides with the aid of turn bar used for printing thick substrates such as paperboard, often used in line with converting operations such as lamination, rotary and flatbed die cutting, and cross perforation. Corrugated press, same configuration as the inline press, sheet fed width up to 120 inches, usually no more than 4 color, limited to one-sided printing, less accurate registration capabilities. But this was the press during the olden days. Now press has been designed in such a way that it can print up to 6 colors with coating and varnishing. So here is next the repeat length. I would like to explain this. Plate cylinders with different diameters can be mounted on many flexographic presses, allowing for variable repeat lengths. Printing a roll of packaging such as gift wrap or uses a continuous repeat, where the same set of images is repeated many times on a continuous stream of substrate. To avoid the plate seam, images may require nesting, an arrangement that creates a staggered effect. Staggering images give the appearance that the design is continuous no matter where the substance is cut. Now the plate types, molded rubber. In olden days, molded rubber use how it is that there is a vulcanized rubber and a matrix use and the protective cover. There is a upper platen heated to 307 degrees and lower pattern heated up to same temperature, and the pressure will be 300 to 1000 pounds pressure. So lbs. Then the molded rubber plates shrink when they are removed from the molding press. Plates films should be adjusted to compensate for shrinkage, which is typically 1.5% to 2% in the direction of the rubber grain and 0.5 to 1% axis across it. Exact shrinkage amounts should be communicated between the artist and plate makers. Line screen is limited to 120 lpi. Registration can be more difficult in molded rubber plates with photopolymer plates. Nesting is required for appearance of continuous repeat. It is difficult to mold accurate rubber plates larger than 24 inches by 36 inches. Larger design must be placed on multiple plates for each other. and the photopolymer plates has come into development. Then how it works that there is a film use, a negative film use, and these are the UVA exposure lamps, and in the down there is a back exposure UVA lamps as well, and it is a substrate where you put the film and the photopolymer plates, and it will be exposed. So the technology is that there is a while washing out in the second stage of processing this unexposed soft resin, the polymer will be washed out with the help of chemicals, and the image area will here remain. So therefore, the line is screening at least 150 lines per inch and can be as high as 200 LPI. The technology has changed today, and there is a elimination of this uh, negative film. It is directly imaging the plate to the in the CDI, which is digital imager. Nesting is required for the appearance of continuous repeat. Position and register device on most modern flexographic presses and designed for one-piece photopolymer plates. And as I told you, direct-to-plate laser imaging is available right now. As I discussed in the previous slide, that plates type laser ablated. What I said that let the plate manufacturer apply on the top of the imaging area of the plate. There is a thin layer of digital film, and they will apply while they are manufacturing the plate. And the technology used here is that there is a special imagers. It's called CTP. Line screen is limited to 100 LPI for tone limited reproduction, but can be 200 to 300 LPI for tints. Tints means half tone. Film is not required here. Design roles can provide a true continuous repeat with a continuous background color. Plates or design rolls image directly on the cylinder do not compensation of the plate elongation. Laser ablating is available for both rubber and photopolymer plates. The next is plates elongation. When designing images for flexographic printing, it is important that understand the effects of plate elongation because flexographic plates are made with soft material and they tend to stretch when mounted on the plate cylinder, sometimes distorting images and text. A circle, for example, may be stretched to look more like oval here. Fortunately, special flexographic software can compensate for plate elongation by slightly distorting images. This can be calculated with the formula. It will come in the next slide. So that's what I would like to explain, that distortion is usually performed within the flexographic software application or the RIP stage. RIP stage means raster image processing before the film is imaged. The amount of distortion depends on the thickness of the plate and the mounting tape used fasten it and on the circumference of the cylinder, the repeat length. In general, thicker plates and shorter repeat lengths increase the elongation. These are the special illustration here to how to calculate in the software, in the Adobe Photoshop, Illustrator. So these are the formula, and it will explain you pi into 2t, which is the 3.1416 repeat length of the plate cylinder, and this is the thickness of the plate mounting tape. And this formula will apply, and you will get the actual distortion unit. To show that image will be printed with the correct size and shape, the design should be output to film after plate thickness has been determined and proper distortion factor has been applied. which means that every thickness of the plate there is a different formula will applied, and you have to input the repeat length as well. Substrates. Flexography is ideal for printing packaging materials because the soft plates can transfer ink to many kinds of substrates, anything from corrugated board to candy wrappers. The quality of a printed product is determined not only by the type of the plate but also by the substrate itself. Different substrates allow varying degrees of ink's absorption, gloss, brightness, and color difference. Here I'm showing you the paper board. What is the effects in paper board? In polymer films, which is polyethylene, polypropylene, and polyvinyl PVC, multi-layered lamination, metallized paper, metallized film, polyethylene coated solid bleached sulfate. And in paper board, you have recycled paper, solid bleached sulfate, coated craft liner board, coated paper, uncoated fresh sheets. And color capabilities in flexography is something because the appeal of packaging is significantly enhanced by color flexographic presses, commonly for offer 6 and 8 colors, and even as many as 12 for limited application. Designers can choose from a number of different combinations, including multiple spot colors and hi-fi printing. What is the method of increasing color gamut by printing 6 or 7 colors process colors? Here is a small illustration. It will explain. Now the color capabilities. Most flexographic inks consist of opaque or semi-opaque pigments to ensure proper ink coverage. The spot colors are usually printed from lightest to darkest. Process colors in inks can made from Process colors inks are made from transparent pigments and can be applied in a sequence. Transparent, transparent substrates such as polypropylene require a white backup plate provide a choke plates as a background for colors. Otherwise, colors would appear flat and translucent. Another technique used for applying inks to the transparent substrate is reverse side printing. The image laterally reversed and colors are printed instead from darkest to lightest. The packaging is then displayed from the non-ink side of the substrate. This provides a scratch-proof surface to the ink layer and glossy finish. In some cases, water-based inks is used for reverse side printing. And I will continue uh, my third chapter into this same flexography and packaging subject. And again, I thank you very much for your time for watching my channel and the subjects which I am teaching you. Please comment what is required to study more. Thank you very much. Goodbye.